Hi, my name is Kalange John Bezareli. I'm going to take you through how to use a Paraview software. So the Paraview software is used to simulate or give you data analysis on 3D models and the physics that is acting upon it. So it tells you how objects act on the physics that's around them. So I'm going to show you a quick demonstration on how we use Paraview. So I'm going to show you through downloads. I'm going to get you through one of these data sets. You select apply. So what comes here is, you see a pipe, but this pipe here comes with the X displacement data, Y displacement data, and Z displacement data. So if I want to visualize the X displacement, I just select X displacement here, and then using this scale here, I am able to know that this this part falls within this range and this part falls within this range of displacement. Likewise for the Y displacement, see the Y displacement, and likewise for the Z displacement, see the Z displacement. So you can be able to gauge the displacement by just looking at the object. I'm going to show you another example that we show you now. Another so this one we are going to see how if you apply a stream of data manyache of particles and they are entering through this cylinder. As you can see, imagine here there is a fan. We are going to see how it acts on those particles. Get so this comes with a number of multiple data. We have the velocity, temperature, pressure, and other types of data as we can see. So we are going to visualize displacement. So here, as I told you in the other first video, by just looking at here, you can see from this scale that the outer layer has the least velocity, while here we are seeing a lot of velocity. But now to visualize it properly, I'm going to use a filter known as the stream tracer. Hold on a minute. The stream tracer, this one, the stream tracer, and we are going to be applying the particles into this fan at an angle. You see, at an angle. So because now we are applying at an angle and here there is a fan, we explain from everyday life you expect it to splash because it is at an angle like this. So let us prove it. You see, since we are applying a stream of fluid, it comes here, makes a splash, and since this is a what, a fan, I can say like a fan. You are seeing here we are having a lot of velocity here. You see, as it comes like this, swirling about the cylinder like this. See, but then behind the fan you are seeing that there is relatively low motion than outside. You see, because now we are applying a stream. You can also decide to simulate when there is actually not applying a stream of particles, but now you are just applying it on particles that are already stable. For example, stable ground, by just going here to the minute. Here to seed type and choosing point cloud. So now we are imagining that the particles or the fluid was already inside and it's acting with the vector field that is already generated by the fan. So we are not seeing the splashing outside of the cylinder, but again we are seeing the movement that is behind the fan you get inside the cylinder. So I go back to the line whereby it's a stream of fluid going inside. I apply, yes, because this is much more interesting. Yes, so I can now give you a better visualization by adding a filter known as a tube. I apply, sort of gives you a solid, so that you know the direction just by looking at it. So I apply another filter to show the arrows, known as give. Okay, gives me a warning. I just say yes. Then I edit this profile. Since we are on the velocity part of it, we look at the velocity, which is v, and velocity, which is v, not the angular velocity, and then we modify the scale to around 0. Let me say 0. Something like that. Apply. You see, now it is showing you that if you are to get this, put this line, is that you applied your, let me say, stream of water. It came like this, oh yes, and then it hit the fan. The fan rotated it slowly while it went down this side, you see. Then it came back up. It came back up like this, but then it increased velocity, increased velocity until it reached here. It was the maximum. It came, then it was on its way moving outside of the cylinder. You see? Yes, and that's how you can actually visualize how the stream of water would act once it is poured into a cylinder that has a fan in it, and behind there is behind it it is closed, you see. So down here is closed, and here it's actually how you apply water. And then down here you are seeing relatively low motion, but as it comes up, velocity increases. Likewise, you can also simulate temperature. Go here, also change to temperature. Yeah, but I already applied the other. Let me not contaminate my data. So one last thing I want to show you is you can also use it with time series data. For example, displacement, velocity, yes, acceleration. So what we can do, we can reset it here. We open, there is a can there, we apply. So what we see, is two objects. One is a sheet and one is a brick, assuming. So we are going to see how these two play with as time goes by. One is above the other, and it is seemingly heavier than this. Yes, so we expect it to fall and crush this object, isn't it? So once we play, yes, as we expected. But now if we want now to visualize the related data with this, we want to know, did this change anything? Did this change anything? So if we want to look at anything, we go to the corresponding data we want to know. For example, this one, you see acceleration, then displacement. Displacement, you are seeing by the time they all fall, they have covered distance. That's why sometimes you are seeing red, but this lower part which was down didn't move at all for the sheet. That's why it is blue. You see, but this one was what? This one was moving much more faster, and that's how you can show how the displacement acts with time on it and has an effect on a body. Okay. Yes. So thank you very much for listening to me. Ciao.